In this video, we will review the relationship between angles and arcs of a circle. There are four situations that we have learned about, and they are: sometimes the vertex of the angle is at the center of the circle, and in that case, the angle is equal to the arc. Sometimes the vertex is on the circle, all right, that's called an inscribed angle, but in that case the angle is half the arc divided by 2. Or if you flip that around, that means the arc is double the angle. Sometimes the vertex is just randomly inside the circle, all right, but not necessarily at the center, just anywhere in the circle. In that case, we have this relationship because we have two arcs now, all right, we have arc X and we have arc Y. So the angle is arc plus arc divided by 2 in that case. And then finally, sometimes the vertex is outside the circle. And in that case, we still have our two arcs. But instead of doing arc plus arc divided by 2, we do arc minus arc divided by 2. And you should do the big arc minus the small arc so you don't get a negative number. All right, so just pay attention to each problem. Ask yourself, which one of these situations are we in? Is it at the center? Is it on the circle? Is it in the circle? Or is it outside of the circle? All right, let's take a look at problem number 1. Well, for this problem, the vertex is at the center. So that's when the angle is equal to the arc. So if the arc is 80, that means the angle must also be 80. For number 2, this vertex is in the circle. So this is the one where we do angle equals arc plus arc divided by 2. So in fact, I think I'll write that down first. We have angle is equal to arc plus arc divided by 2. The angle is what we are looking for, so I'm just going to go ahead and say x is equal to. And the two arcs are 170 and 70, and that's going to be divided by 2. Okay, so that's going to be x is equal to 240 divided by 2. So x is equal to, well, I might as well put it down here, 120 degrees. For number 3, this angle is outside the circle. So the formula for outside the circle is angle is equal to arc minus arc divided by 2. In this case, the angle is what we're looking for, so I'm just going to go ahead and put x is equal to. And we need to do the big arc minus the small arc, so that's going to be 170 minus 72 divided by 2. Okay, so that's going to be 98 divided by 2. So that's going to be 49. For number 4, this vertex is at the center of the circle. So keep that in mind, because this is the situation where the angles and the arcs will be the same. I had to make a quick edit there. We need to find the measure of arc xy. Okay, so since these angles are 120 and 100, I should be able to find the third angle by subtracting from 360. So if I do 360 minus 120 minus 100, that leaves 140. So that means this central angle is 140 degrees, which means the intercepted arc is also 140 degrees. Again, when the angle is at the center, the angle and the arc are the same. Okay, this vertex is not at the center of the circle, so this is merely in the circle in a random way. So the formula for that is that the angle is equal to arc plus arc divided by 2. So the angle is, again, what we are looking for. So the angle is going to equal 40 plus 80 divided by 2. So that's going to be 120 divided by 2. So that's going to be 60 degrees. This angle is clearly outside the circle. And in that case, the formula is that the angle is equal to arc minus arc divided by 2. And this needs to be the big arc minus the small arc. Now the angle is what we are looking for, so I'm going to go ahead and say x is equal. Okay, now I have to be a little bit careful here because I only see one arc that's given to me. So let's be careful here. So here is the 140 that goes from here to here. That's one of the arcs, but the other arc is the one that goes from here to here. All right, that's the big arc and the small arc. They only gave me the big arc, so how do I find the small arc? Well, this is a diameter. See how it goes through the center? That means this colorful part up here is a semicircle. So I should be able to get the green part by subtracting 140 from 180. So of course, if I do 180 minus 140, that's going to be 40. So the green arc is 40. Okay, so that's why I'm going to do now 140 minus 40 divided by 2. So that's going to be 100 divided by 2. So that's going to be 50 degrees. For number 7, we are supposed to find the measure of angle GEH, and that's going to be this angle right here. Well, we already know that this part of the circle is 64. This arc is 64, which means that this central angle is also 64. So I see that I have a diameter here. So this right-hand side is a semicircle. So I should be able to find the remaining part by subtracting from 180. So if I do 180 minus 64, that is 116. So that tells me that this angle is 116 degrees. Okay, for number 8, this angle is inside the circle. So again, that formula is going to be angle is equal to arc plus arc divided by 2. In this case, they gave me the angle. The angle is 45, so the 45 goes first. Now, the arcs are x and 75. So I'm going to have x plus 75 divided by 2. So the way I solve an equation like this is I will multiply both sides of the equation by 2. That way these 2's will cancel each other out. So that's going to give me 90 is equal to x plus 75. Then I can subtract 75 from both sides. So So that's going to be 15. So x is equal to 15 degrees. Number 9 is outside the circle. So this is the one where the angle is equal to arc minus arc divided by 2. All right, make sure you begin to memorize these formulas. All right, when it's outside, that's when it's arc minus arc divided by 2. This time we're given the angle. All right, the angle is 26 degrees. So 26 goes first. Now we have to do the big arc minus the small arc. Okay, the two arcs are here and here. All right, but we need to do the big arc minus the small arc. The big arc is x. So I have to do x minus 30 divided by 2. Again, for an equation like this, when you have a variable on the inside of this fraction, you want to multiply both sides by the denominator, multiply by 2. That way these 2's will cancel each other out. So that's going to give us 52. So this is going to be 52 is equal to x minus 30. And then we can simply add 30 to both sides, and that's going to make 82. So x is 82 degrees. All right, this vertex is at the center. All right, we are told that RT is a diameter. So this is at the center. So just keep that in mind, remembering that in this situation, the angle and the arc, the intercepted arc, will be the same. So if this is 64, that means then the arc is also 64. Now, the thing we're supposed to find is RS over here. But we're looking at a semicircle. So the entire arc has to add up to 180 degrees. So we should be able to simply subtract from 180. So if I do 180 minus that 64, notice I get 116. So this should be 116. All right, that was too easy, so I'm calling an audible, and I'm deciding to also find the measure of angle P. That's going to be a little bit more interesting. So angle P, as you can see, the vertex is outside the circle. So when I deal with that, I need to use the formula that says that the angle is equal to arc minus arc divided by 2. Okay, so I'm looking for the angle, so I can just call that x. All right, so x is equal to. Now, I really need the big arc minus the small arc. So what are these arcs? Let me see if I can make this really clear to you. Maybe if I color this angle. So angle P goes like this. Okay. Now look at these intercepted arcs. So I have one arc right here. All right, that's the 116. But I have another arc right here. These are the two intercepted arcs. Hopefully you can see that the purple arc here is a semicircle because of the diameter RT. So that tells me that the purple arc is, of course, 180 degrees. So when I do big arc minus small arc, I am talking about 180 minus 116 divided by 2. Okay, so that's going to be 64 divided by 2, so that'll be 32. So the measure of angle P is 32 degrees. So for problem number 11, you can see that the vertex of the angle is inside the circle. So this is the type where the formula goes angle is equal to arc plus arc divided by 2. So you guys need to begin to memorize these formulas. Now in this case, we're given the angle. What's the angle that I'm given? 30, all right? The angle is 30, so that's why I'm definitely going to put 30 in there first. Okay? What are the two arcs that we've got? Do you say 60? You're thinking of an inscribed angle when it's on the circle. All right, so we have 15, but the other one is what we're looking for. So we're going to call that X. Okay, Devin, you had a question? No, oh, you were going to, yeah, just jump in there, buddy. So that's going to be X plus 15. All right, what am I going to do next? We need to multiply both sides by 2 in a problem like this. All right, that's how we will get the X out of there. So if we multiply both sides by 2, so that way these 2's will cancel each other out, right? And that's going to give me 60 is equal to X plus 15. Okay, subtract 15, Devin says. Devin D. Okay, so what's that? So X is equal to 45. Any questions about that? Okay. Number 12. Notice that this angle is outside the circle. Out. So that means we're going to be using the formula that says the angle is equal to arc minus arc divided by 2. All right, you need to memorize that. Memorize that when it's outside the circle, arc minus arc divided by 2. Okay, Ashley, do I know the angle, or am I going to put X there?
X.
Ah, what? 40. There you go. All right, this time they gave us the angle, so I'm going to go ahead and put 40 equals. Okay, now what goes in the numerator, Ashley? What are the two arcs?
150.
150.
And X.
And X. So 150 minus X. Okay? All right. Charlie, what do I do now? You multiply, all right? So here's where we're going to multiply both sides by 2. That way these are going to cancel each other out. And we're going to get 80 is equal to, I messed up that 5 a little bit. Let me try that again. All right, so that's going to be 150 minus X. All right, what do I do now, anybody? Subtract 150 from both sides. So what's that going to be? Negative what? 70. Negative 70. So then that means 70 is equal to X. Okay, any questions about number 12? All right, for number 13, this angle is at the center. So focus on that. That means the arcs and the angles will all be the same. So what are we supposed to find? Let's see, arc JGI. Okay, JGI. So look, here's arc JGI. It's going around the long way. J, G, all the way to I. All right, well, this seems pretty straightforward. I could add up all of these angles, all right? All these arcs and angles, I could add them all up. What's a quicker way to find this arc that I just drew? Subtracting 70, all right? This arc is the whole circle except for 70. So the quickest thing to do would be to do 360 minus 70, and that should give me the arc. So what's that going to be? 290. All right, so this must be 290 degrees. And that would be the same thing you got if you added 135 plus 69 plus 55 plus 31. Any questions about number 13? For number 14, this vertex is in the circle. It's not at the center, but it's just randomly in the circle. So we know that this is the situation where the angle is equal to the arc plus the arc divided by 2. Okay? Aiden, help me set this up. What goes first? What goes for angle? What goes for angle? X, right? The angle is X, so I'm just going to put X right there. All right? What goes in the numerator, of course? 32 plus 54 divided by 2. Okay? Just execute that, and what's the final answer, anybody? One more time? 43. 43, does everybody agree with 43? Okay, any questions about number 14? Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.